Given this rational function under a radical sign, it's really a radical function with a rational function underneath. G of x is equal to the tall square root of x minus 5 over x. Find the domain of this function g. So I see that there's an invisible 2. I don't really see it, but there is an invisible 2 in that little hook. So this is an index 2 radical. 2 is an even number, so we have an even indexed root. That means that there's a restriction on the radicand. The radicand being the stuff under the radical sign, it can never be equal to to a negative number. It can never be equal to a negative number because of our even index root. So let's find the values of x in the domain. We'll find the values of x that make the radicand greater than or equal to 0. That's in respect of the even index root. But there's another thing we have to watch out for. We also have to make sure the bottom of this fraction is never 0. So x can never be 0. We'll deal with that at the end. Let's start with finding the values of x that make the radicand greater than or equal to 0. Okay, set the radicand x minus 5 over x greater than or equal to 0. So here we have formed a radical inequality, all right? Or I should say a rational inequality. It's a rational inequality because that's a rational function. It's a fractional function. We're going to make a sign graph to solve this, to find these x's. And we're going to do it this way. Step 1, make sure you have a single fraction on the left side. And we do already. We have the x minus 5 over x is a single fraction on the left side. It's greater than or equal to 0. Step 2, we're going to factor. Well, you know, you can't factor it, so consider the top a factor over the bottom factor greater than or equal to 0. Okay, so this is a little star. We're going to have a little star out here in front of this step because we'll come back to it later. Step 3, we're going to set the bottom of this fraction equal to 0 and the top equal to 0 and solve to find our critical numbers to partition our number line. So when we solve the bottom equal to 0, we get x equals 0. We set the top equal to 0, we get x minus 5 is equal to 0. And that gives us x equals positive 5. So step 4, we use the real solutions to partition a number line. So here's an x-axis number line we're going to draw. And we're going to bust it up into pieces using these real numbers we just found. 0 and 5. So partition this number line. And we're going to take this x-axis. We're going to consider the sign of each of the top and the bottom. The sign on the top and the sign on the bottom in each of the regions. And then the entire fraction, the sign on the entire fraction. So I'm going to draw a little fraction in each of the regions to represent the parenthesis x minus 5 over parenthesis x. In the first region, I have parenthesis over parenthesis, middle region, and the right region. Now, choose a value of x to the left of 0. Like, let's choose x equals negative 100. Plug it into x minus 5, you get negative 100 minus 5. That gives you a negative. Plug it into the bottom, you get negative. And a negative divided by a negative is a positive. Next, we look at the middle region. We have to choose a number for x between 0 and 5. Let's choose x equals 1. On the top of the fraction, x minus 5, 1 minus 5 would give us a negative 4. And on the bottom, x would be 1. That's positive. So we have a negative over a positive. A negative divided by a positive is a negative. And for the region on the right side, choose a value for x greater than 5, like let's say x equals 100. Put it into the top part of the fraction, x minus 5. We'll have 100 minus 5, which is positive, over 100, which is positive. A positive over a positive is a positive. Now we go back to down to step 7, and that says to shade the regions that satisfy the step that had the star in it. Step 2, that's where we had our completely factored fraction on one side, and then inequality sign and 0 on the other side. We want our entire fraction to be greater than or equal to 0. And what does it mean to be greater than or equal to 0? It means we want the entire fraction to be positive. So go back and highlight the regions where the entire fraction turned out to be positive. That happened in the right region and on the left region, but not in the middle region. So we'll shade the right region, we'll shade the left region. And now we'll deal with the endpoints. The original inequality had a greater than or equal to when we started this portion of the problem. that implies that we include our endpoints because of the equal portion, but because it's a rational function, we always have to exclude the values that make the bottom of the fraction 0. So we can keep everything except the x equals 0. So that means that we'll write our answer in graph form. In graph form, we'll draw an x-axis, and we'll shade everything from 5 to infinity and everything from negative infinity to 0. We'll include the 5 with a boxy bracket, but we exclude the 0 because we don't want x equals 0. And to write this in interval notation, we express the left interval as everything from negative infinity to 0 with both open brackets, and then the right interval, everything from 5 to infinity with closed bracket on the 5, because we're including the 5, open bracket on the right of infinity. And that is our domain for this function. And you'll notice that we were very genuine about not allowing x to be equal to 0, which is something we were worried about at the very top line when we started our solution. And indeed, we excluded the 0, so we do not have a 0 denominator, and everything's good. That was a complicated problem. That's something that you should study, because you could see something like that maybe in an exam somewhere, because that's a good problem.